Hello everyone, this is Anu here. Let's go ahead and see what are the basic terminologies we use, what are the technologies coming into the system designs and all. Without knowing the base, there is no meaning going in deeper into that system design. So what I'm going to discuss is given in the screen. First thing is I would like to discuss about is what is DNS, then how the internet actually works, graph query language versus REST versus gRPC. What is the difference between these three protocols? Then what is the difference between WebSocket and the REST and the REST API from scratch? What is meant by REST API and what are the components? Then what is the difference between HTTP and HTTPS? That is hypertext transfer protocol and secure hypertext transfer protocol. Then monolith versus microservices. Then message queuing system like Kafka, then CAP theorem, and what is meant by ACID properties and base properties of databases. Then networking components like load balancer, etc. These are the basic things we should understand before moving ahead deep into the system design. First of all, let's go ahead and discuss the primary component, that is the DNS. What is meant by DNS? Why DNS? What are the components of DNS? And these are the topics which we are going to see today. Let's go into the DNS. What is meant by DNS? DNS by name, it is called domain name system. It is a tree structure system starting from root to go to the authoritative server. Okay, so DNS is the system. DNS is a system. It's a global distributed network of servers and protocols that translate human readable format. Human readable format means for any web address, there will be one domain name will be there, just like google.com or yahoo.com, youtube.com. And those address has been mapped to the IP address or the corresponding IP address. That is, if it is a Google, this is the IP address of Google 142.250.80.46. This IP address is being mapped to google.com on domain name. How it is happening when we type google.com in the web browser, how it is being translated into machine understandable IP address. This is how this whole process happen inside the DNS server, and then how that computers used to route the traffic across the network. These are the common things we are going to see in the DNS or domain name system. Let's go ahead and see why DNS. These are the topics I'm going to cover. What is DNS? It's already covered. What are the DNS servers available? And what are the domain name, what is in DNS hierarchy, what is root server, what is top level domain servers, and then authoritative DNS server, and then we will see some of the practical use cases. So why DNS exist at the first place? It is very easy to understand and memorize the names rather than memorizing the IP address or numbers. Suppose if you want to memorize this IP address for YouTube, is it difficult? Is it easy to understand or memorize this IP address rather than just youtube.com? It's always easy to memorize youtube.com because humans are designed to memorize the names rather than numbers. So without DNS, we had to memorize this IP address to reach that web address. With DNS, we just need to type that domain name, either google.com or yahoo.com or youtube.com. Okay. Then what are the core problems the DNS is resolving? If you see in the computers which are connected to the internet, those are all connected to the IP address. Every system will be having some IP address. Okay. It is very difficult to memorize all the IP address rather than we can memorize the name. We can connect those systems through that name. The DNS system will translate those name into IP address. That is what the job of DNS server or DNS system. Okay, DNS system will translate those names into IP address. Okay, billions of domains are there. There is no single system which is handling the billions of domain names. Rather than it is distributed one. Next come to the flexibility. A domain IP can change. Suppose if I am doing one IP address today for my domain, I can change the IP address tomorrow and just change the mapping so that the end user won't affect by the changing of the IP address. And the speed, DNS uses aggressive caching, that is time to leave. The most lookups are answered within milliseconds from nearby servers. So if you consider what's going on behind the scene, humans will type the euron.one, just an example. Then that name will go to the DNS system. The DNS system will translate the name. Then it will give the IP address. Using that IP address, we can access the web server. Domain name is the human readable address for resources on the internet. It is having a specific structure. We need to read from right to the left. And rightmost part is a period or dot. It is called the root domain. Then it will go to the left side part, that is called the TLD or top level domain. Then it will go to the um, second level domain, that is we can call it as our domain name. Then it will go up to the subdomain. This is how it is being divided. And the full domain anatomy, every domain name is built-in layers, read from right to left. Okay, let's break down this one into that pieces. Host name, learn is called the host name, euron is called the domain name, and one is called the TLD or top level domain. If learn is considered as a host name, then euron.one. It is called the fully qualified domain name. Okay, so this is the anatomy. Learn is the subdomain, euron is the second level domain, and one is the top level domain. And there is another one dot is also coming from there, that is called the root domain. Top level domain or TLD, that is the rightmost part. It can be .com, .org, .net, .one, .io, like that. Okay, these are managed by ICINN or accredited registries. And then there are generic GTLDs are there, and CCTLDs, that is for the country wise, are there. If you see the DNS records, let's go ahead with the other one. There is second level domain. Second level domain is the domain we purchase from any of the domain vendor like Namecheap or GoDaddy.com, like that. And subdomain, that is the first part of the domain domain name. We used to give www or learn.xyz.com, that learn, or apa.xyz.com, mail.xyz.com. So those part is called the subdomain. There are different type of DNS records are there. One is called the A record. A record, it will map the domain name with the IPv4 address. If it is 4 A's, then it is going to map the IP address, that is IPv6 address, with the domain name. This is CNAME. This is a alias for one domain to another. Okay, that means www.euron.one to euron.one. That is the alias name. MX is the mail server, NS is the name servers, and TX is the text info, that is for this SPF and verification we use. Let's go to the next topic, that is called the DNS hierarchy. Okay, DNS is not a single server, it is a tree-shaped distributed system. Okay, on top there is a root system, then it will go to the TLD, then it will go to the subdomain, then finally it will go to the authoritative server. This is how this tree structure is going on. Okay, no single machine knows everything. It is a distributed system. All the DNS records are distributed across the globe on these servers. Let's go ahead and see what are they. At top, we have the root DNS server. There are 13 clusters globally. I have already shown you what are the 13 servers. Then that request will go to the corresponding TLD. If it is if the domain FQDN is ending at .com, it will go to the .com TLD. If it is .one, it will go to the .one TLD. If it is .org, it will go to that .org TLD server. Then from that TLD server, the request will go to the authoritative server for the domain search. Suppose if it is euron.one, we from the root server we got the .one. .one will transfer to the next level, that is name server, that is euron.one. The authoritative server will give it is having all the details about this servers and its domain mapping, and authoritative server will give the IP address corresponding to that particular domain. First level 1 is the root. Now all the TLD name servers and 13 logical cluster ATM. Anycast mean the hundreds of physical servers globally. Level 2 TLD, that is easttld.com.one.org, has its own servers. They know the authoritative name server for every domain under them. And then come to the level 3, that is authoritative, that is hold the actual DNS record for the specific domain. It will be hosted on Cloudflare or Route 53, etc. Next topic, we can see this. What is the root server? Root server are the starting point of every DNS resolution that is sent, where either it can be cached or non-cached. Okay, they are the foundation for the entire DNS system. It starts from the root server. Okay, if you want to see what are the root servers available, let's see what are the root servers. There are 13 logical clusters are available. Okay, let's go ahead and see those 13 root servers. Let's copy this command. That is, we are using dig command to find out all the 13 root servers. Sorry. See, this has listed all the 13 root servers. It's not can list the list all the root servers. This command, this dig @a.root servers.net, that is giving from the root. It is giving the names of our short names. Let's go ahead and see referrals, not answers. Ask a root server about euron.one and it replaces .1. Suppose if you are requesting to the root server what is euron.one, it is not going to give you all the details. Instead, what it is giving, it will give where this .1 domain resides or .1 TLD top level domain resides, and all that details will get from the root server. Suppose if you're asking to the root server, where is this euron.one? Now I am asking where is this euron.one to the root server, and it will give the details where it is residing. Okay, it is giving all the details of this .1 TLD from root server. Now we are into .1 TLD top level domain, and it is saying where all this .1 TLDs are residing, and we can go to this many top level domain, and then we can find out where is the authoritative service residing. Here is IP address for this servers, and this is IPv6. First one is IPv4 address corresponding to that one. Second one is IPv6 address. Then next we can see any cast in action. Your query route to the nearest physical root server. The root servers are distributed across the globe, and wherever the nearest root server are available to that server, our request will be transferred. 13 global and 1600 physical servers are available, and referrals not the answer. That means whenever we ask the root server, we'll get the referral to the TLD, that is top level domain .org, .com, .net, like that. We will get that referrals. From that referral, we will go to the next level. Now, from we ask to the Zola where is euron.one. From there, it will be transferred to the root server. A root server will say, I don't know, but you can go and ask .1 TLD. Okay. Then we'll go to the next. We will go out and see what is top level domain servers. What is top level domain servers? Sits in the middle of the hierarchy. Okay, they are the gatekeepers for every domain under the TLD. Suppose if it is .com, .org, .one, .ca, there are hundreds more TLDs are there. Okay, and TLD servers are the middle layer. It is having the NS record, not A record. Okay, that is the TLDs are handling the name server record. From .1 TLD server, we got the name server details, that is ns1.euron.one. That is delegation record it is giving. Then it will go to we will get the referral to the, now from the TLD, we are getting a referral to the authoritative DNS, where we have the complete DNS record. Next, let's go ahead and see what are the type of TLDs or top level domains are available. Okay, there are 4 kind of TLDs are available. One is the generic TLD. Generic TLD is .com, .net, .org, .info, .io, .ai. These are the ICANN accredited registries are there. There are few new GTLDs are there. Generic TLDs are there. That is .1, .am, .dev, .cloud, .tech, etc. Okay. Then country-wise TLDs are there. That is .ca, .uk, .de, .in, .au. That is the national authorities. Then come to the sponsored one, that is government and all. We have GOV from the education platform. We have this edu.mil, etc. Next topic, we are going to see what is meant by authoritative DNS. Okay, the authoritative name server is the final authority for a domain. It holds the actual DNS record, the grounded truth that all the servers are pointing to. Okay, this is the last part, that is authoritative DNS. The authoritative name server is the final authority for a domain. Okay, this is holding the complete IP address and other details for a domain. It holds the actual DNS record, the ground truths that all the other servers are pointing to. The authoritative name server is the final authority for a domain. And it holds the actual DNS record, the grounded truth that all the servers are pointing to. Okay. This is the last part, that is authoritative DNS. The authoritative name server is the final authority for a domain. Okay, this is holding the complete IP address and other details for a domain. It holds the actual DNS record, the ground truths that all the other servers are pointing to. Authoritative means source of truth. That is a source of truth means, suppose if I am asking learn.euron.one, it will go to the authoritative DNS. Just come to the authoritative DNS to get the IP address corresponding to that particular DNS domain name. Okay, here we have primary name server and a secondary name server or backup name server. If something goes wrong to the primary name server, we'll get the details from the secondary name server. Okay. Then SOA means start of authority record. Every zone has a SOA record, metadata for the authoritative server. Then come to the practical. Let's go ahead and see some practical commands to learn more about the DNS and DNS in action. Okay. Then first thing is basic error code lookup. We can use the nslookup for identifying what is the basic details. Let's go ahead and see. Okay, nslookup, if you are giving the nslookup command, nslookup euron.one, it is giving the server and the address corresponding to that. Okay, we have got for euron.one, we have got around 4 IP address. Then you can also use dig command, dig, to get the exact details. No. Instead of nslookup, if you are using Linux based system, you can use dig command, dig. This will also give the similar result. This will also give a similar record. See, if you see this one, this is a similar result we are getting. And next command is dig command, dig, and I'm using instead of going through the IP ISP, that is Internet Service Provider, we can go to Google or Cloudflare directly where this domain names are getting registered. 8.8.8.8 is from Google. If you are using 1.1.1.1, that will go to the Cloudflare. Let's see both. We will use a dig command or nslookup command to find out these details. Yeah, sorry. That is the issue with the PowerShell. Now it is giving. Suppose if I'm using DAG and the Google server name with the euron.one, we are getting the exact result bypassing the Internet Service Provider. And if you want to go ahead with the Cloudflare, we can use Cloudflare IP address. That is, instead of 8.8.8.8, we need to give 1.1.1.1 IP address we have to give. If you are executing this command, again, it is giving the similar result. The dig command. Then we have to go ahead and see the next command, that is the referral response from the top DNS tree. Let's see from what is the referral report we are getting. We are going to ask the root server. What are the things we have seen before? At first, we have taken the basic nslookup, that will give the basic IP address from where it is mapped. Then we are querying a specific resolver. Resolver means either it is a Google, bypassing the ISP. We will go to the Google or Cloudflare. They will resolve this IP address. Okay. Then we are going to ask the root server. Okay, I'm going to ask the root server where this euron.one is registered. Let's go ahead and see the first root server, that is a.rootserver.net. I'm going to use a dig command, dig command to this root server and asking where is euron.one. It is giving all the details about that server. Okay, yeah, from here we have started. It is giving all the details. It is giving some authority section. These are the root servers you need to look up, and it is giving corresponding IP address in IPv4 as well as IPv6 address. It is giving. Now we have requested details to the root server. Then from the root server, then we can get trace the full path. For tracing the full path, we can use the plus trace. Dig space plus trace euron.one. It will, what are the details it is giving? It is giving the from the root. It will go to the .tld server. From .one TLD server. From .one TLD server, it will go to the ns1.euro.one. Then from euro.one, we will get the AR report. This is how this path is. Let's go ahead and see this command. Plus trace, it is giving all the hops. All the hops means from root to the TLD to the second level domain, then second level domain to the host name to the complete history we are getting. We will be getting all the complete IP address after that. This is going to hop to each. Hop means from one server to which second server to third server. That is called the hop. As the hop count is increasing, latency also increasing. And next, we'll go ahead and see the query records. If you are asking for any specific report, we can use this command. Suppose if you're asking for the short name, then we can use the plus short. It will be the short name, that is the IP address we are getting. Suppose if you want the name server details, then we can use ns. It will give the name server details. This is hosted in the Cloudflare account. Then if you want to see the mail server details for this particular domain, okay, now mail server, that we need to open dig euron.one mx. We need to know the mail server details. It will give the mail server details. Let's see. It has given the mail server details. These are the mail server details associated with this particular domain. Then come to the TTL ID. This is given all the TTL ID details for this particular domain. Okay, from what are the things done from browser? Whenever we do some search on a particular website in our browser also will have some cache. It will keep, there is a TTL, up to that time the browser will cache the data. Then it will go to the resolver, if it is a Cloudflare or Google, there also cache will be there, and it will go and check the cache whether it is there or not. If it is not there, that is a cache miss. That cache miss, then it will go to the root. From the root, it will give the TLD. Now we'll go and ask the TLD. TLD doesn't have the information, complete details, and TLD will give to which authoritative server you need to go. Then we'll go and hit that authoritative server, and the authoritative server will give the complete detail what is IP address associated with that particular browser. From browser it will go to the resolver. Resolver, it can be 8.8.8.8 for Google, or 1.1.1.1 for Cloudflare. Okay, if the details is not available in cache, then it will go to the root server. If the root server details, from the root server, it will give the details back. Now we have to go ahead and look up this root and this TLD. If it is .one, you have to go ahead and see the .one TLD. Now it will go to the .one TLD and get the details of what is the domain name. and it will go with that details. It will go to the authoritative server. From the authoritative server, it will give the IP address. Uh, the this is how the go is. This is how we are getting the domain name address. Then we'll go ahead and see what is next. Yeah, this is all about this DNS system. Then now we'll go ahead and see a working principle, how it is going to work in real time. We'll be taking the example of what euron.one. I want to know how I'm getting the euron.one website when I type euron.one on the web browser address bar. I'll be typing euron.one in the browser. Okay, yeah. Okay, in my PC, I'll be typing euron.one. Then it will first it will check the browser cache whether it is already available or not. That DNS details is available or not. It will check the browser cache. If it is not available, then it will go to the resolver. Resolver also have the cache. It will say up to the detail. It will say the cache. If it is available there, it will take it from there. There is a second stage. It can be. Okay, this we already discussed the Google and Cloudflare. Okay, if the resolver doesn't have the cache, then it will go to the resolver is checking in the cache. If it is a cache means, then it will go to the root server. Okay, from the root server, we have 13 root servers. I have already discussed. From the root server, it will give the details back to which TLD we need to go ahead and ask. You will get the details of the top level domain. Using that top level domain, we will go to that particular top level domain and get the .one registry. In the .one registry, how many domains are registered? Those details will get. From there, using that details, we'll go ahead and ask the authoritative DNS server. The authoritative DNS server will have the details of all the IP address and give that IP address details to the resolver, and to the browser we will get that. Using that IP address, resolved IP address, we can get the web resources. What is hosted in that particular IP address, we can get that details. This is how this flow is. Okay, from browser to resolver cache miss, it will go to the root server. From the root server, it will get the details of top level domain. From the top level domain, we will get the details of authoritative server. From the authoritative server, we will get the DNS resolution. That resolved IP address will be given back to the resolver. It will be saved in the cache for at that time. Then it will give to the browser. This is how this DNS resolution is working. Hope you enjoyed this video about the DNS servers. That's all about this DNS and how DNS working and all. See you in the next video. Thanks for watching this video. Have a good day.